Hello students, today we are going to do an interesting yet simple activity to understand some concepts of circular motion. When a body moves in a circular path, it experiences certain force directed towards the center around which it is moving. This is called centripetal force. The same body experiences another force directed away from center. This is called centrifugal force. It arises from the inertia of body. During circular motion, both centripetal and centrifugal forces are equal. Have you ever played kikli with your friend? Remember, it feels like all your body is getting attached to center where our hands are tight, right? This is due to centripetal force. In case one of you leaves hands, the other person is pushed forcefully to one side due to centrifugal force. Today, I am going to show you a very simple activity using an empty thread reel and an alpin, which will prove that velocity of an object varies inversely with the radius of circular path if same torque is applied. I am using an empty thread reel and alpin. Make 4 small holes in one half side of the reel on both faces so that alpin can pass through it. Let's start doing the activity. I have taken the thread reel and the alpin. Now, what I'll do, I have done 4 holes on one side of this alpin from the center and 4 holes on the other side, on the other face. As you can see in this, now I am inserting the alpin in the first central hole, which is the center of this reel or center of mass of the reel, and I will rotate it now. It is rotating very fast like a fan blades. Like fan blades, it is rotating. I am applying some torque which is giving it angular momentum. Now I will insert this alpin in second hole away from center, and remember, I will apply the same force or same torque as before. Now let us watch what is its velocity. It takes a bit time to insert it. Now I am giving it the same torque. So let us look. The velocity is same or lesser than before? It is less than before, a bit less. Now I insert the alpin in the third hole. Let us watch the velocity now. The velocity is now more or less lesser than the second one even, and now I am inserting it in the edge hole farthest from the center. The velocity is least. It is the least velocity. So as you see, when the alpin is in center, the velocity is maximum with the same torque, and velocity decreases as we move away from center. As the distance from the center increases, the velocity decreases. So why does this happen? What is the reason behind it? Let's find out with some circular concepts. Why is the circular velocity of reel decreasing when we move away from center? In each case, I am applying the same force or the same torque. Since the mass of reel is constant, so angular momentum is also constant. Also, when an axis is in center, centripetal and centrifugal forces are equal. Some basic questions arise. Why is the reel moving? Obviously due to torque given by finger, which gives angular momentum to the reel. Then why does it stop? Due to friction. Why does the velocity decrease when we move away from center? Due to moment of inertia. Yes, moment of inertia I is equal to mr square. M is the mass of reel and r the radius. When we move away from center, the radius of circular motion becomes more than before. Thus, moment of inertia becomes much more. Remember r square. Since angular momentum L is equally applied in each hole, where L is I into W or omega, I is the moment of inertia and W angular velocity. So as I increases with an increase in radius, the angular velocity will decrease accordingly. So got my point? I hope the reason for decrease in circular velocity is clear now.